Hello, welcome to Unit 10, Lesson 1 with Professor Blackman. Today we're going to have an introduction on matrices and use them to solve systems of equations. We're going to look at the matrix, we're going to determine the order of the matrix, we're going to take systems of equation and create an augmented matrix from them, and then we're going to look at Gaussian elimination or Gauss-Jordan elimination. Right here in these notes, we have row equivalent operations. Basically, it tells you what you can do. You can interchange two rows, multiply a row by a non-zero constant, and you can add non-zero multiples of one row to another row. And that will be very important as we go to our Gaussian elimination. All right, let's go ahead and get started on some examples. All right, so for order of a matrix, we look at it at row by column. Row by column. So how many rows are there? Well, this is row 1, this is row 2, and this is row 3. This is column 1, and this is column 2. So the order of this matrix, we would say this is a 3 by 2 matrix. Here we have 1 row and 4 columns. So this is a 1 by 4 matrix. Here we have 3 rows again and 1 column. So this is a 3 by 1 matrix. All right, let's look at some more examples. So for an augmented matrix, we're going to take and look at all the coefficients on the left side and the constants that are on the right side, because these will be in standard form. So we have a 5, a 3, and a negative 11. We have a 3, a negative 1, and a negative 1. We put a vertical line there, and then we close the matrix in a bracket. So this system is now represented by this augmented matrix. All right, here we'll do it again. 1, 1, 1, vertical bar, 57. Negative 2 for x, 1 for y, z has no value there, and 3. X is 1, y has no value because there's a 0y that's understood to be there, and a negative 1 for z, and a 6. And this is how we turn a system of equations into an augmented matrix, just writing the coefficients. All right, for Gaussian elimination, what we're trying to do is we're trying to take our matrix and get it into 1, 0, 1. And then this can be any number, and this can be any number, and this can be any number. Once we have that, we can see that y will equal this number, and then we take that value and substitute it in, and we can figure out what x is. So let's go ahead and start by putting it into an augmented matrix, just like we just did. So we have 4, 2, 11, 3, negative 1, and 2. Now, we're trying to turn this 4 into a 1. So the easiest that I can see is we're going to take this 3, and we're going to do row 1 minus row 2. Okay. And from there, that's 4 minus 3, which is 1. 2 minus a negative 1 would be 3. 11 minus 2 gives you 9. And then we're not going to do anything with row 2. Now, I need to turn this 3 into a 0. So what I'm going to do is I'm going to take row 2, and I'm going to subtract 3 times row 1. So 3 times 1 would give me 3, and then subtract that from 3, and that would give me the 0 that I need. I'm going to go ahead and put row 1, since we're not doing anything with it, here first. So 3 times 1 is 3. Take that away from 3, we get 0. 3 times 3 is 9. Take that away from -1, you get -10. And 3 times 9 is 27. Take that away from 2, and you get -25. All right, well now we need to turn this -10 into a 1. And we can do that by multiplying row 2 by a -1/10. Because row 1 is already in the form that we need. It's got the 1 and other numbers. And so here, multiply by -1/10, you get 0. -1/10 of -10 would be 1, which is what we're trying to do. And then 25 divided by 10, negatives would cancel, and that would be 5/2. All right, so now that is Gaussian elimination. So we can say that y equals 5/2. And now we can take this 5/2 and put it into the x plus 3y equals 9 that is in row 1. And so that would give us x plus 3 times 5/2 equals 9. So that's x plus 15/2. And I'm going to change this 9 into 18/2. And so x gives us, subtract 15/2 from both sides, 3/2. So this is an ordered pair that has a solution 3/2, comma 5/2, because that's our x and our y. Now, with ordered pairs, this is a system of equations, so we can always check the solution. So I would plug that in and check. So I'm going to do that. And so that's 4 times 3/2 plus 2 times 5/2. And that needs to equal 11. In the second equation, that's 3 times 3/2 minus 5/2, and that needs to equal 2. So 2 cancels 4, and that gives us 6. 2 cancels 2, plus 5 equals 11. So we're good there. And this is 9/2 minus 5/2, which would equal 2 is 4/2. So 9 minus 5 does give you 4, so we're good there. So that is our solution to our equation, and I'm ready to move on to the next one. All right, now I'm going to show Gauss-Jordan elimination, which is actually what I prefer more. So with your augmented matrix, you're going to have it be 1, 0, 1. So it would look just like Gaussian elimination, except you take it a step further and put a 0 here. And then this will be any number, and this will be any number. What I like about Gauss-Jordan, by taking it that step further, when you're done, it's x equals a and y equals b. You don't have to substitute back in because it's x equals a and y equals b. So let's go ahead and do Gauss-Jordan elimination now. So we're going to create our augmented matrix. 5, -2, -3, 2, 5, -24. And again, we're going to start by turning this 5 into a 1. And I can see that we can do that by doubling this 2 and taking it away. So we're going to do R1 minus doubling R2. So R2, we're going to do nothing with it. 2, 5, -24. But R1, double this 2, take it away from 5, you get 1. Double the 5, you get 10. Take it away from the -2, that's -12. Double the -24, so it'd be -48. But subtracting -48 would be adding 48. So this is a 48 minus 3, so 45. Okay, now I need to turn this 2 into a 0. So I'm going to do R2 minus twice R1. So 1 -12 and 45 stay there. And then we're going to do double 2. Double 1 becomes 2, so 2 minus 2 gives us 0. Double -12 would be -24. And since that's a negative, so that'd be plus 24. Plus the 5 gives us 29. Doubling 45, we get -90. And when we add that to -24, we get -114. Now we need to turn that 29 into a 1. So we're going to do 1/29, row 2. All right. And we're going to do nothing with row 1, so we're going to just recopy that. And that's 0, 1, and -114 over 29. So we know it's the second part of our ordered pair is -114 over 29. So now we just got to figure out what x is. So now that that 1 is in that second row, second column, we can do row 1 plus 12 times row 2. So 0, 1, -114 over 29. And so 12 times 0 is 0, plus 1 gives you 1. 1 times 12 is 12, plus -12 is 0. And so then we just got to add the 45 plus 12 times -114 over 29. So first we need to put this into the fraction over 29. So 45 times 29 gives you 1305 over 29. Minus 12 times 114 is 1368 over 29. And subtract that, you get -63 over 29. And that is our ordered pair. -63 over 29. All right, let's look at another example. All right, so we're going to start by putting in an augmented matrix. 3, 4, 7, -5, 2, and 10. So the combination of 3 and -5, I'm going to do double R1 plus R2. So doubling R1 will give me 6, and 6 minus 5 will give me 1. Some people will start this by doing 1/3 of row 1, but that gives me a lot of fractions, and I try my best to stay away from them, especially after the last problem. So double R1 is 6 I'm going to go ahead and write R2 down. Double R1 is 6 plus a negative 5 is 1. Double 4, you get 8. 8 plus 2 is 10. Double 7, you get 14 plus 10 is 24. Okay. Then we're going to do 5 R1 plus R2. That will turn this column 1, row 1 as a 0. So we have 1, 10, 24. 5 times R1 is 5, plus a negative 5 is 0. 5 times 10 is 50, plus 2 is 52. 5 times 24 is 120, plus 10 is 130. All right, so now we need to turn that 52 into a 1, and the easiest way to do that is doing 152 of R2. So row 1 we're going to leave the same. So 152 of 0 is 0. 152 of 52 is 1. And 152 of 130, those are both multiples of 26. So that's 5 over 2. All right, so now we need to take and do row 1 minus 10 times row 2. So row 2 is done. So 10 times 0, 0. Subtract that from 1, you get 1. 10 times 1 is 10. 10 minus 10 gives you 0. And then 24 minus 10 times 5 over 2 is 24 minus 2 cancels the 10 turns into 5. So 25 giving you negative 1. So that's negative 1. So we get our ordered pair as negative 1, 5 over 2. And if you want to check, which I always do recommend, you can plug that in. You plug it into equation 1. You get negative 3 plus 4 divided by the 2 gives you 2. 2 times 5 is 10. 10 equals 7. So that's correct. Check in equation 2. Plug in the negative 1. You get 5. 2 cancels the 2 plus 5, and that does give you 10. So that is good. All right, let's look at our next example. All right, let's start with putting our augmented matrix. So we have 1, negative 3, 8, negative 2, 6, and 3. So right here, we already have the 1 in that spot, so that's already done for us. So we're going to do start with row 2 and add it to twice row 1. So row 1 we're going to do nothing with. And double 1 and add to negative 2, you get 0. Double negative 3 and you get negative 6. Add that to 6, you get 0. Double 8, you get 16. Add that to 3, you get 19. So at this point, we have an equation that basically says 0 equals 19. So our answer is no solution. And we can just stop there and we're done with that problem. Now, if this 19 right here was a 0, then we would have the equation 0 equals 0, which we would then say infinitely many solutions. And so that's just examples of special cases that you may see when solving using Gauss-Jordan elimination. That's all I have for you today. Happy studying.